Okay, so Transformers and math. What do they have? What do they have to do with each other? So Optimus Prime is a robot and a truck, but he's still the same guy. Bumblebee is a robot and a car, but he's still the same guy, even though he looks different. Ironhide's the same. He looks different, but it's the same guy. Yeah, this pizza is 3/8 of a pizza. It's also 37.5% of a pizza, or 375 thousandths of a pizza. But it's still the same guy. It's the same amount of pizza. Okay? Does that make sense? It is the same amount of pizza, even if we use different numbers. So that brings up the question, why do we need all three numbers? Anybody have any thoughts? If you have thoughts on why we need, go ahead and type that in the chat. On why we might need all three numbers, type that in the chat. We'll give you about a minute to do that, and we'll move on. Okay, so let's look at why. I know we're going in a different direction, but bear with me for a minute. How many pairs of shoes do you have? Type in the chat the number of pairs of shoes that you own. 5, 3, 8, 4, 7, 10. Daniel's getting a little out of control there. Actually, a lot out of control. 100. All right, so now no matter what the shoes look like, their main function is to protect your feet. They might look good or whatever, but their main function is to protect the soles of your feet from whatever's on the ground. However, each type of shoe serves a different function. In the chat, you can respond to this or not. Would you wear this type of shoe, this sandal? Would you wear this to play soccer, or baseball, or football, or volleyball, or basketball? Would you wear a sandal to play sports? No. You'd slide all over the place and break your ankles, right? That would be super uncomfortable, and it would hurt. Now, let's say you were going somewhere and your mom said, I want you to look so, you have to dress up. This is a fancy, nice place we're going to. A wedding, a funeral, some really nice restaurant. Would you wear this shoe out here? Would you wear this tennis shoe? Probably not. Now, some people would, and I would. I'm just going to be honest with you. Maybe not the yellow, but. And I'd get some funny looks for that. That's okay, I'd live with that. But most people, normal people, would not wear a tennis shoe somewhere that is supposed to be nice or fancy, right? Now, would you wear this shoe, this boot? Would you wear that to the beach? I don't imagine you would, because that would tear your feet up, get sand all in there. You would have no skin left on your feet. With the sand, like sand blast your feet. That would not be fun at all. Okay. So while the shoes basically serve the same function to protect your feet, in particular the soles. They have different functions, right? These have different functions. How many of you say, Mom, I want 40% of that pizza, please? Anybody? Okay, no. Nobody's going to use percentage for that. But what you might use is a fraction. Hey, I've got 5 pieces of pizza, you can have 2 of them. So you get 2/5 of the pizza. That's much more reasonable. Okay? On the other hand, have you ever been to the mall and seen a big red sign outside the store that says, shoes, 2/5 off? They say 40% off, right? They say you get a 40% discount. So the numbers serve different functions. Percentages are important when we're dealing with what in particular. There's one thing that uses percentages a lot. Anybody know what that one thing is? Type it in chat. Stores, coupons, those have to do the same thing. Money, yes. How many of you plan on having a job when you get older? Okay, how many of you plan on buying a home or a car or clothes? Darius, I hope you buy all of those things, especially the clothes or food. Or food. Okay? You're going to have to deal with percentages when you deal with money because it's a big part of money. Alright. We deal with decimals when we deal with money too, in terms of cents, right? Which is something you guys are probably accustomed to at this point. And that's why we need to know how to transform, there's where that transformer thing comes in, one type of value to another. Alright. We've already done fractions to decimals. We divide the numerator by the denominator and we get the decimal value. Okay? So top dog gets the house. Remember that? We also said you can use TBO, top in, bottom out, if that helps. This gives you the, so dividing the numerator by the denominator gives you the decimal value. Are there any questions on this? Okay, I'm going to give you just a few minutes to answer. Okay, so now that we have gone through those, the answers are 0.625 for 5/8. 4/5 is 8/10, and 9/10 is obviously 9/10. So the answer slides on this presentation are mostly wrong, so we're going to skip them when we get to them. Decimals to percent is also one that we have already done. Oh, no, it's not. We did decimals to fractions. Decimals to percent is not one we've done, but it is pretty easy. Okay? What you do is you take the decimal value and you multiply by 100. Or if you want to cheat, you take the decimal and you move it 2 places to the right. How many places? Hold up your fingers and show me. How many places? And some of you already watched the math antics on it, and that's great. So you know what's coming, and that's good. 2 places, good. It's always 2 when you are, thank you, Connor, when you are converting decimals and percentages. So 75 hundredths becomes 75%. And so if I give you 0.6, and I move it 2 places, 1, 2, well, I have to fill in that extra bump, so that equals 60%. And if I have 3.5, I'm going to move it 2 places, and I have to fill in that extra place, so that's 350%. Yes, percent can be over 100. We'll get to that much later on this year. Okay. Try these guys on your own. I'm going to give you just a few minutes to do that. Alright, good job, guys. Now, percent to decimals is one of the Daniels I don't remember. Oh, Daniel Howard pointed out. Now we're just going to go backwards. We're going from percent to decimal. We're going to move it 2 places to the left now. And it's the same process. But we're just going to move it 2 places to the left instead of to the right. So, if I'm given, I'm going to use the same numbers we used here. If I'm given 32%, we all know that even if you can't see the decimal, it's there, it's right there to the right. I'm going to take it and move it 1, 2 places, which means that equals 0.32. Okay? If I have 5%, we know the decimal is right here. I'm going to take it and move it 2 places. Once again, I have to fill in that extra bump with a 0, so that is 0.05. And then the last example I'm going to show you is 2.5%. We have to move it 2 places, and we have 0.025. We start wherever the decimal is. And if you can't see it, it's always to the right. Give me 1 second, Daniel. Here are your practice problems. I'm going to give you a second to work on them. Right. Good job, y'all. Okay, moving on to the next thing. Decimals and the fractions. We've already done this. We've seen it a couple of times. In fact, there are 3 steps to turning decimals into fractions. Who can tell me in the chat the first step, turning decimals into a fraction? Step number one is read it. You can tell me step number two. Write it. Good job, Robert.
Nathan, give me a second. We'll come back to that.
And the last step is simplify it. Very good. Okay. The base 10 thing we'll get to in a minute, okay? So, hold off on that. Remind me of that just a minute in case I forget. Decimals and the fraction. Read it using place value. Write it as a fraction. Simplify it if you can. Okay? So we have, Okay. So all we need to do is divide by 10. Is that right? Tell me in chat if that's right or not. No,
very good. That is not correct.
Okay. Now, I'm not sure why Yoda made it into a transformer slide, but he has a very good point. Do not rush, guys. We make mistakes when we try to go too fast. Okay? Find a pace that you're comfortable with, but don't rush through it, alright? Okay, don't go to the dark side either. Bad plan.
There's a song called Don't Rush.
Okay. Awesome. Alright. The denominator, this is another good way to look at it. The denominator depends on the place value. Hundreds, the denominator is 100. Tenths, place value is 10. So you can look at it like that if that helps you remember. Now, here's something pretty cool right here. If you don't know this, it's worth getting this slideshow just for this. When you have a decimal value, the number of digits is the number of zeros you're going to have. 3 digits, 3 zeros. 2 digits, 2 zeros. So that's the number of zeros you're going to have in the place in the denominator. Alright? So we have 3 digits and 3 zeros in the denominator. 2 digits and 2 zeros in the denominator. 4 digits and 4 zeros in the denominator. That's a pretty good tool to use. And then don't forget to simplify if you can. Alright. So, here's Yoda again giving you one last piece of advice. And then he leaves the transform. Alright, good. So we got a couple more things, and then we're done. Fractions into percents and percents to fractions. Okay. I'm going to be honest with you, the easiest way to do this, fractions to percents, is to go fraction, decimal, percent. So divide the numerator by the denominator, and then read it, write it, simplify it. You got to do those 2 steps. The other way is what somebody said was base 10. Okay? If you can turn the denominator into a 10, 100, 1,000, you can also do it that way. Especially get it into hundreds. That will help you turn it into a percentage. Alright, percentages into fractions. Percent to fraction is pretty easy, guys. You put the number over 100. 50% is 50 over 100 or 1/2. 10% is 10 over 100 or 1/10. Okay? Because percent, the word percent means out of or per 100. Alright. Here's some more exercises I want you to try on your own. Let me give you some examples before you try these. I'm going to write them on the paper so we can see them. Let's see, 17%. That's horrible. 17% equals 17 over 100. And I can't simplify that. 5% equals 5 over 100, which equals 1/20th if I reduce by 5. Okay? 75% equals 75 over 100, which then equals 3/4 if I reduce by 25. turning a fraction to a percentage. Let's do one we know, 3/4. I'm going to divide that and come up with 0.75, and then I'm going to move my decimal point. 1/5. I'm going to divide that and get 0.2. I'm going to move my decimal and get 20%. Okay? Everybody got that?